Welcome to Cooking with Water. Today we'll be showing you the 3 steps of the water cycle: evaporation, condensation, and precipitation. We now will have 3 featured chefs to show you each step of the process.
Alright, for this recipe we're going to grab a pot, bring it over to your sink. Cool water is going to work for the recipe for evaporation. Fill it up. That's good. And bring it over to your stove.
The cool thing about this recipe is that the temperature of your stove is absolutely up to you. If you want a slower evaporation, use a lower heat. If you want a faster evaporation, use a higher one.
Evaporation is the process by which water changes from a liquid to a gas or vapor. It's the primary pathway that water moves from the liquid state back into the water cycle as atmospheric water vapor, as well as a cooling process that takes up heat from the environment. Increasing the wind and temperature results in an increase in evaporation. Heat, energy, is necessary for evaporation to occur. Energy is used to break the bonds that hold water molecules together, which is why water easily evaporates at the boiling point, 212 degrees Fahrenheit, 100 degrees Celsius, but evaporates much more slowly at the freezing point. Now that we know what evaporation is, we can dive right in.
Here, more molecules are leaving the surface as evaporation increases. Wow, we are really cooking now.
Condensation is the process which water vapor in the air is changed into liquid water. Condensation is crucial to the water cycle because it is responsible for the formation of clouds. These clouds may produce precipitation, which is the primary route for water to return to the Earth's surface within the water cycle. Condensation is the opposite of evaporation. With a cold glass of water, the condensation is fairly easy to notice. The cold glass causes the water vapor in the air to cool down and form tiny beads of water on the surface of the glass. The molecules in these beads of water are grouped far more closely together than they were in their gas phase. Another way to visualize condensation is to put a lid over a pot of boiling water. When you flip over the lid, you will see all the water forming on the pot.
Next, I'm going to wait for the water to start boiling at roughly 212 degrees Fahrenheit or 100 degrees Celsius. Precipitation requires clouds, but the cloud particles do not have enough mass to fall because their fall speed is not large enough to overcome updrafts which support the clouds. As condensation continues to add water to those cloud particles, gravity eventually pulls them towards the Earth as precipitation. For precipitation to happen, first tiny water droplets must condense to even tinier dust, salt, smoke, or smoke particles, which acts as a nucleus. Water droplets may grow as a result of additional condensation of water vapor when the particles collide. If enough collisions occur to produce a droplet with a fall velocity which exceeds the cloud updraft speed, then it will fall out of the cloud as precipitation.